Let P be a point chosen uniformly at random in the interior of the unit square with vertices at, okay, so like the standard unit square. The probability that the slope of the line determined by P and the point 5/8, 3/8 is greater than or equal to a half can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, I'm going to start by sketching out the geometry here. And I'm wondering if this will be something I want to turn into. It's going to be something to do with areas, basically. Okay, yeah, let's find this point 5/8, 3/8. So it's about there. Okay, and we take a point, we generate a point P randomly. So we take a point P chosen uniformly in the interior of the square. So it could be there, could be there, could be there, could be there. And then we compute the slope of the line that goes through that point and our point here. And we want the probability that the slope is greater than or equal to a half. So what I'm going to do instead is I'm going to shade the region of the square where the corresponding point would result in the slope we want. Okay, so there's a line of slope 1/2. No, a half, not 1. There's a line of slope 1/2. Does this intersect above or below the origin? So this line has a slope of 3/5, which is greater than a half. So that's, so I guess it intersects above like that. So if my point is generated anywhere in there, the slope will be greater than half. Okay. I just need to compute the area of that shaded region now. So I guess, what's the best way to do this? Probably need to find that point. Actually, no, what I can do, I can write this as an integral. Let me first just make sure. Let's find the equation. I'm going to find the equation of this line. Because if I know the equation of that line, I can write this as an integral. Okay, so the line, let's call it f of x, is equal to, well, hold on. Y is equal to 1/2x plus, nope, let's do it as y minus 3/8 divided by x minus 5/8 is equal to a half. So y minus 3/8 is equal to x over 2 minus 5/16. Y is equal to x over 2 minus 5/16 plus 3/8. 3/8 is 6/16. So y is equal to x over 2 plus 1 over 16. Okay. So the area, I'll break it up into two areas, A1 and A2. A1 is equal to the integral from 0 to 5 over 8 of this function, x over 2 plus 1 over 16 dx, x squared plus x over 16 evaluated as 0 and 5 over 8. So that's 25 over 64 plus 5 over 8 times 16, whatever that is. I'll come back. Let's just simplify this now. So this is 50 over 64 times 2 plus 5 over 64 times 2, 55 over 2 times 64. So that's A1. A2 is equal to the integral from 5 over 8 to 1 of 1 minus f of x maybe the straight geometry approach would be easier, but I don't want to have to solve for all the intercepts and all that. So 15 over 16 minus x over 2 so I have 15 over 16 minus 15 over 16 times 5 over 8 minus 1 plus 25 over 64. Okay, I'll probably put this over the same common denominator we did before. So I have 15 times 8 over 2 times 64 minus 15 times 5 over 2 times 64 minus 2 times 64 over 2 times 64 plus 50 over 2 times 64. 15 times 3 minus 2 times 64 plus 50 . 15 times 3, 45 plus 50 minus 128. Have I made a mistake? This area should still be positive. Am I missing a number? I've done something wrong here and I can't even find my arithmetic mistake. Because this A2 should still be positive. Integral from 5 over 8 to 1 of 1 minus f of x dx. 1 minus x over 2 plus 1 over 16. One minus 1 over 16 is 15 over 16. Over 16x minus x squared, evaluated at 5 over 8 and 1. 15 over 16 minus 1 minus 15 over 16 times 5 over 8 minus 25 over 64. You put everything over the same denominator again. Well, let me write this first as negative 1 over 16 minus 15 times 5 over 2 times 64 plus 50 over 2 times 64. We need to multiply this by 8. Negative 8 over 2 times 64 minus 15 times 5 over 2 times 64 plus 50, 2 times 64. Why am I getting a negative number? This function is positive. If x is equal to 5 over 8, I get 15 minus 5 over 16, positive. If x is equal to 1, it's positive. What on earth am I screwing up here? I must be doing something very stupid with the arithmetic. Integral of x over 2. Oh my god. So my first area is wrong as well. Oh my god. X squared over 4 plus 1 over 16x. Okay, 25 over 4 times 64 plus 5 over 2 times 64. This is 35 over 4 times 64. One over 4 plus 15 over 16. Wait, negative minus negative 25 over 4 times 64 plus 5 over 16 times 15 over 16 times 5 over 8. Oh. Fifteen times 5 over 16 times 8 is 2 times 64. Eleven over 16. This is 150 over 4 times 64. Um, 16 is 2 times 8. This is 2 times 2 times 8 times 8. So 11 times 16 over 16 squared plus 25 over 16 squared minus 150 over 16 squared. Eleven times 16 is 160 plus 16, 176. Let's do 176 plus 25, 201, 201 minus 150, 51 over 16 squared. That's A2. Okay, finally, A1 plus A2 is 51 plus 35 over 16 squared. 86 over 16 squared. Let's write this as 86 over 8 times 8. No. Two times 8 times 2 times 8. 86 over 2, 43. 43 over 2 times 8 times 8. 43 looks prime. Certainly not divisible by 2. Okay, so 43 over 2 times 64. So this is the probability that I get, finally. I mean, the way the question is phrased, we need to add these together. So 128 plus 43 is equal to 171. Yeah. I mean, I can't believe I screwed this up for such a long time because I didn't integrate properly. But this is really the only part of the problem that's like a key to the approach. That's the any point inside this region will connect with this one with a slope greater than 1/2. Right? If I take this point, it clearly has a very steep slope. That point is just barely greater than 1/2. Anything outside the shaded region gives a slope less than 1/2. So we're just finding the area of that shaded region. Final answer I get is 171. Sorry it took a long time. I'll let you know if I have any mistakes. Thanks for watching.